Welcome. Thank you all for joining us. Good evening, afternoon, or morning, depending on what part of the world you are joining from. We are humbled to say we have people here right now from all over the globe. I think you can see in the chat how many places. I am Angela McCrae, board member of the Cosmobiology Institute, and it is my honor to welcome you all to today's event, An Evening with Vincent Godbout, Quantitative Astrological Research with Practical Examples. I would like to begin by reading the mission statement of our organization. The Cosmobiology Institute is dedicated to the empirical verification of relationships between cosmic phenomena with organic life and to the practical application of these observations and discoveries. The Cosmobiology Institute is dedicated to the application of scientific methods to determine the nature of things, regardless of whether those discoveries may be comfortable or uncomfortable for some people to accept. As a nonprofit organization dedicated to furthering scientific understanding and developing applications that improve the lives of people, the Cosmobiology Institute provides a range of services that are free or involve minimal cost, as well as services that can be further developed by private businesses and governmental agencies without intellectual property constraints. Open source software, training programs, and publications are some of the forms in which Cosmobiology Institute provides or will provide these services. I encourage you all to go to cosmobiology.org to view more information about our organization. This evening, we welcome back one of our board members, Vincent Godbout. We have planned an hour and a half for this presentation, but we'll be spending the last 30 minutes answering your questions and letting you know about our future plans. Please feel free to ask questions in the chat during Vincent's presentation. Also, there will be a short break in the middle of his presentation where we can answer a few of those questions. At the end, if you have a question that you would like to ask verbally, please use the raise your hand icon at the bottom of your screen so that we can get to your question efficiently and unmute your microphone. First, I would like to welcome Santino Mancuso. Santino is the author of the book, The Astrology of Bipolar Disorder, and has made over 700 YouTube videos. The book and many of his other contributions are under his birth name, David Cochran. He is also a founder and board member of the Cosmobiology Institute. Welcome, Santino.
Okay, thank you, Angela. This is an exciting night. Really excited to have Vincent here. He is one of the leading astrology researchers in the world today. He's written several research articles that were published in Correlation Magazine. If you're not familiar with Correlation Magazine, it's a peer-reviewed research journal in astrology. And as probably all of you know, if you really get deep into research, it's a massive undertaking, usually done by groups of people at an academic institute or research institute. So he devotes a tremendous amount of time and effort to the research, and he brings many original insights. We're going to learn about some of these original insights this evening. And he also collaborates with other researchers. Vincent and I have had many discussions. We help each other out, getting feedback. It's an essential part of doing research. He's just a wonderful person and a wonderful researcher. I'm really excited to have an evening with him. Also, just to let you know a little bit more about Vincent, to do his research, he's also developed astrology software called the Mastro Expert System. It's very sophisticated software that he's used to help pioneer these new levels of research. So he's taking on this whole big issue of research, doing everything possible. And to give you a little background, he was a professor of mathematics. He co-authored 3 mathematics courses, adapted a best-selling book on differential and integral calculus into the French language. So I'm honored to introduce to you Vincent Godbout. It's all yours, Vincent. Yay! So Vincent, you can share your screen and
I'm going to
start this
share.
up.
Hello, everybody. I'm very happy to be here with you tonight. It's going to be in 2 parts. The first part is most devoted to give some guidelines and tips about research. If you're a researcher, maybe you won't learn much. The second part is about example of my own. It's going to be more technical. I'll do my best to make it as clear as possible. Let's begin. You have a lot of time to read the title. So part one. I begin with evidence-based astrology. The gap between refined model building and the lack of experimental validation in astrology is concerning. Unlike other fields, astrology rarely evaluates the effectiveness of its models. This focus on theory over experimentation is detrimental to the discipline and undermines its advancement. Consensus exists on basic interpretations, but advanced methods often lead to disagreements among the community of astrologers. If there's no better way of resolving crucial issues than through debate, astrology cannot be taken seriously as a discipline. Many astrological concepts suggest quantifiable properties enabling research to produce evidence. This approach is essential to put an end to the speculation, denials, and contradiction that damage the discipline. Without large-scale testing, astrology relies on personal observation, peer arguments, and debates rather than evidence-based practice. We spend our time looking for the best method in the best book by the best author. To illustrate evidence-based astrology supported by conclusive facts, here is an interesting metaphor. The famous Galileo challenged Aristotle's belief that heavy bodies fall faster. For 2,000 years, this idea has been the subject of debate, with philosophers and scientists offering various explanations as to why heavy bodies fall faster. Legend says that Galileo settled the debate on falling body by simultaneously dropping weights of different masses from the Tower of Padua. All weights hit the ground at the same time, disproving Aristotle's theory. This illustrates how problems can be solved and truth sought without always relying on authorities. The main problem in astrological research: 1, the data scarcity trap. 2, the non-falsifiability trap. 1, the data scarcity trap. A common issue in astrological research is the lack of data and small sample sizes. We often rely on too few cases to validate our methods. Validating an astrological idea requires more than a few dozen cases, as small samples can lead to random artifacts and coincidences. In astrological research, increasing the number of subjects helps differentiate between chance observation and those that stabilize. To assess sample size, monitor the effect across variables. Initially, many seem significant, but as data grows, the size of the sample grows, some lose significance and are dropped. We stop adding data when observations stabilize. The non-falsifiability trap. More damaging than small sample sizes is the lack of validation methods. We risk the non-falsifiability trap as described by philosopher Karl Popper. For a statement to be tested, it must be falsifiable. Popper states that a theory is valid if it's falsifiable, meaning it can be tested and potentially refuted by observation or experiments. A theory is valid if there is an observation or scenario that could refute it. If it can be tested or proven false, it is non-falsifiable. Proposition formulated in such a way that they are always true, whatever the circumstances, cannot be falsified and are therefore invalid. We see a lot of that in astrology. With assertions that are impossible to refute, we manage to find that every technique is almost always right without even realizing it. So we are in the world of belief. A simple example will illustrate non-falsifiability trap. Suppose our favorite planetary dominance method for Hemingway gives the sun. We'll say, it's obvious, he was creative, charismatic, and proud. If our planetary dominance method gives the moon, we'll say, oh yes, he had a great imagination, and according to Gotland's work, the moon is associated with writers. If our method gives Mercury, we'll say, of course, he was a journalist, a writer, it works. If our method gives Venus, we'll say, yes, he was an artist, he was handsome and charming. If our method gives Mars, we'll say, it's obvious, he had a love of accidents, he was a war correspondent, he was macho, he loved bullfighting, safaris, and firearms. If our method leads to Jupiter, we'll say Hemingway traveled a lot, and on top of that, he was showered with honors. He's a Nobel Prize winner. No doubt he's Jupiterian. If we get Saturn, we'll say, I'm not surprised. He was severely depressive. If we get Uranus, we'll say, yes, he was individualistic, original, unpredictable, nonconformist, and brilliant. If we get Neptune, we'll say, yes, he was an alcoholic. If we find Pluto, we'll say, I'm not surprised, he committed suicide. In other words, we're always right. How to avoid this problem? By making really falsifiable statements. Choosing a research topic and sample size. These two elements are interrelated, as we will see. Choosing a research topic. Although it's tempting to research something that fascinates us, it can be problematic. For example, a Quebec astrologer researched ADHD but struggled with data collection, gathering fewer than 200 cases. Despite seeking help from the astrological community, the response was insufficient. Moreover, diagnoses are unclear, and celebrity examples from Google are unreliable. We cannot confirm if Monica Bellucci or Tom Cruise really have ADHD, as we can read on Google. Speculation is common and definitions are problematic. This brings us to the sample size. Choosing sample size. If the astrological effect is strong, a small sample might suffice. However, if the effect is weak, as is often the case in astrology, a large sample is necessary to observe it. There's an imaginary example. So now concentrate because it's going to be a little bit numerical. Suppose someone claims to use telekinesis to make a six-sided die land on 6. We control the die to prevent trickery. As in astrological research, the goal is to exceed chance. With 60 rows, we expect about 10 successes, 16.6%. How many sixes are needed to believe in telekinesis? 60 on 60 rows? We don't need 100% success, as perfection is unrealistic and often signal cheating. Some astrologers claim 100% success, likely lying consciously or to themselves. How many successes out of 60 rows would convince us of the telekinesis power? Observing 40 successes clearly exceed chance. But for a lower number of successes, at what point would we believe in their powers? This decision is not entirely subjective. Probability theory provides objective criteria for determining this. For example, the observation of at least 25 successes, which is a success rate of 41.6%, 25 on 60, correspond to a chance probability of 4 in 1 million of occurring by chance, according to the binomial distribution. Surprising, just 24 is nearly impossible, 4 in 1 million. By the way, here's a common way to write probability of 4 in 1 million. You write p value for p for probability equal 4 divided by 1 million, but you can write also 0.0000004. By the way, there's you don't have 6 0. You have 1, 2, 3, 4, 5, and the 4 appear on the 6th position. This is 1 divided by 1 million. And the more common that we can see in Excel, for instance, is 4, letter E, minus 6. What does it mean? E, my exponential basis 10. It means implicitly that you are 10 exponent minus 6. Minus means it's in the denominator. So the minus 6, 10 minus 6 is this. 1, so 4, 4, minus 6, 1 with 6, 0 at denominator. We have two options now with that figure. We assert that telekinesis power, we assert that the telekinesis was just lucky with a 4 in 1 million chance of at least 25 successes. That would be the skeptical denegator point of view. 2, you conclude that telekinesis has genuine power. We performed a statistical hypothesis test. We just done it now, which is just a common sense approach for testing astrology. As the p-value decreases, we're more likely to choose option 2. The more it's low, the more we choose option 2. If you got 1 divided by 1 billion, you're more inclined to choose the option that he's got power. This is exactly what we aim in astrological research. If the telekineticist achieves 15 successes, 25%, instead of 25, is this enough to believe? 15 instead of 10. Let's revisit our probabilistic criterion. The binomial distribution indicates that there is a 6 in 100 chance of obtaining at least 15 successes by chance. It's not so impressive. The probability of 6 divided in 100 is not very impressive. We'd likely think the telekineticist was just lucky with 15 successes rather than proving their power. However, doubt persists, especially if we believe in telekinesis. To dispel doubt, we need a larger sample size. For instance, rolling the dice 10 times more, 600 times instead of 60, would help determine if there's a real effect. If the telekineticist maintained the same 25 success, that was not impressive, but it means 150 successes out of 600 attempts. Due to the larger sample size, the result could be more impressive than before, with 15 out of 60. Is it enough to convince us? In fact, the binomial distribution shows a 1.4 in 10 million chance of achieving at least 150 successes, the same 25%, but now it's large sample out of 600 rolls by random chance. So the same 25% success rate that was not significant for 60 rows becomes highly significant for 600 rows with the same 25 success rate as before. In this new protocol, we're now even more inclined to believe in the telekineticist power compared to the initial 46.6 success rate with 25 out of 60 attempts that we've seen at the beginning. This is similar to astrological research. A strong effect needs a small sample, but a weak effect, like you find, for instance, in Gauquelin's work, common in astrology, requires a large sample for significant results. This brings us back to the initial issue of choosing the phenomenon to observe. Compiling a list of world champions to assess chess talent astrologically will quickly yield too small a sample if the effect size is weak. Sometimes we must sacrifice our main interest to ensure a sufficient sample size. Before analyzing some examples, 3 fundamental questions need now to be addressed. 1, control groups. 2, scores. 3, validation. 1, control group. For each group, to avoid, research group, to avoid speculating about interpretable and elegant random artifacts, use a control group and to see what chance looks like with random data devoid of the feature under study. In other words, compare your sample group's observation with the chance findings from your control group. For the control group, using real subjects born around the same time and place as your sample is an option, but it's unreliable. Instead, use the shuffling method by Ruiz and Tarvainen for the control group, which I will now explain. The control group could generally be at least 50 to 100 times larger than the study group. Here I was to create a control group using the shuffling method. Take all the astrological charts available for your research sample and shuffle as follows. 1, mix all the years together. 2, mix all the dates, including day and month together. 3, mix all the birth time, hours. And 4, mix all the geographic coordinates, longitude and latitudes together. At each series of these 4 combined shuffles, you generate the same number of imaginary charts as in the original sample. By repeating these, you can create a very large number of different imaginary astrological charts with the same characteristic as your study group. So you can repeat from 50 to 100 times and it's going to be okay. This Monte Carlo method that was impossible at the time of Gauquelin and before, you need a computer to do that. This Monte Carlo method generates perfectly random data that matches your study group astronomically, historically, and geographically. And the shuffling method is more reliable and less laborious than using real subject. Scores. Whoops. Scores. For example, if we suspect Venus in Aries is linked to homosexuality, we compare its presence in the gay group. This has been given to me by a Russian researcher. She suspects that. So she has to compare its presence, Venus in Aries, in the gay group with its presence in the control group. To compare, we need converting the many Venuses in Aries observed in gays into a single score that measures what we want to demonstrate. Simply here, we calculate the mean for the sample group and the control group, expecting the gay group means to be higher. Then we apply the mean test. It's a statistical test, a simple test, to check if it's significant, aiming for a p-value below 0.05, below 5%. Remember that the term significantly relates to the p-value. A lower p-value indicates greater significance. It can be more complex. Finding a homosexuality signature might require combining multiple factors into a single global. So signature is very important because you're closer to astrological practice. You might combine multiple factors into a single global score. For example, to calculate this single global score for each of the sample in control group, we could add together the mean score of all significant astrological factors. And finally, validation. In research, it's crucial to preserve certain data to test the result and confirm their validity, ensuring findings are genuine and not mere coincidences. For example, use 2/3 of the sample for research. What Santino calls to build a model. How do you call that?
The
Santino?
training
data. The training data with which we built your model, and reserve 1/3 for validation, which you call test data, I think. Yes, it's equivalent. Leaving in this 1/3, you got to leave it intact and unexamined. If you begin to look in it, you're going to be tempted to cheat a little, to adjust your model. This is not what it's completely aside, completely intact and unexamined to be a real validation. After completing research on the sample, duplicate the process with the validation data. If results are confirmed with a significant p-value, we can speak of a discovery. For validation, it's crucial to follow strict data collection. It's not as crucial for your sample data that you call. Would you repeat the name again, Santino? The building model
the training data.
Your training data, you don't have to follow strict. It's better not to cheat yourself, but it's not as strict that what is needed in their validation. You need rules for selection of the data to avoid cherry picking and editorial retention. Cherry picking without a clear selection rules, we risk picking and including subjects that boost results, lower the p-value, and falsely enhance significance. The reversal is editorial retention. Instead of include, we exclude. Publishing only positive or significant results, omitting negative results, as Big Pharma does all the time. In a single study, this amounts to excluding subjects who do not support the desired outcome, leading to data biased toward favorable results. We tend to minimize these methodological flaws, saying, oh, I've just done it for 2 or 3 data. No. If we do that, it's because we don't recognize the harm they cause in our search for truth. Now I finished part 1. We can stop a few minutes, but we stay together and we will, for a
Yeah.
few minutes, answer questions if you have questions.
So Vincent,
I have
yeah, I wanted to, Peter, I wanted to introduce you, if you don't mind, so that everybody knows. Peter is one of our founders at the Cosmobiology Institute. He did have a question that he would like to, or a comment that he would like to make, and then everybody else just put things in the chat and we'll get those answered as well. Thank you, Peter.
Wonderful. Thank you, Angela. I want to emphasize the importance of evidence-based research. And I want to give you just a couple of examples. One is a system that we built for NASA in 1983 to 1990. And it was built with 7 Bendix processors, avionics. It was the world's first fly-by-wire system. And it flew on the ground for 30 years or so without ever failing. And you could pull out a board and you could pull out a memory, and it had 7 memories and 7 power supplies and 7 processors and 7 buses. And it had 2 out of 3 voting on every one of the tasks. And the processor was rated at 10 to the -5. And we were able to mathematically prove that based on the design for the entire system, the result was 10 to the -10, the probability of failure. So we got 5 orders of magnitude improvement out of the architecture of the system. And we were able to prove that mathematically. A completely counterexample is all of the vaccine stuff that was going on during COVID. Robert Redfield, who was the head of the CDC, came out a few months ago and admitted they had been hiding all of the evidence that the vaccines were in fact causing thousands of deaths and thousands of permanent life maimings. And they actually had gone around to everybody in the CDC and said, we are shredding all of this negative data and we're not going to use it in any way in anything that we're doing. He also admitted that they had done absolutely nothing to point out that there were alternatives to the vaccines, which were medications that are well known already, that have been shown to work better than the vaccines. So there's an example of the total absence of evidence-based research. I have several other examples that I won't go into, but we've recently built new hardware, new software that is the most secure system ever created. And all of the formal proofs that we've come up with to prove that the hardware correctly satisfies its specification is an example of evidence-based assurance in the computer hardware design world. So those are just a couple of examples, and I want to thank Vincent for what he's done this evening already in the first half of putting a mathematical and probabilistic base on everything that we are trying to do in the Cosmobiology Institute. I think this is spectacular. This is a wonderful evening of demonstrating how valuable this research is going to be in the future. So thank you, Vincent, enormously for what you have done already.
Yes, thank you, Peter. I think Vincent, also to back up what he's saying, I think it was a very good explanation of p-value. I think there's a lot of us, even though we are involved in research, that may not have a full grasp of that. I think your explanation was spot on. Thank you for that. Zach Robbins has a question. As an astrologer, wouldn't we want to consider the transits and all that entails, as well as the sample size, perhaps controlling for the transits?
I'm not sure I understand. Would you repeat slowly? Because
Sure.
I'm French. So
I know.
what about the transit? What about the transit? I missed
He
what
was
you said.
asking, shouldn't we consider the transits when you're talking about all that the transits are involved in? I think it like the control group, for example.
I'm going to address that problem in a few minutes, but I'm not sure of the meaning of the question.
I
Are
think
we
Zach,
considering transit for research, or should we consider our personal transit when we design a protocol? I don't know what the question means.
Santino, did
Yeah,
you
I
have
can,
something?
I can add a little bit. I
Thank you.
believe, yeah, I believe what he's getting at is to include the consideration of transits in the analysis of the data. And that is not an issue of a control group. That's an
Yeah.
issue of having more what we call predictor variables. And there's no limit to the number of variables you can analyze. So the answer would be that's up to the researcher. If the
Exactly.
researcher feels that they want to include transits, if that's realistic, if that fits into it, you can. But no research design is anywhere near perfect. You have to deal with the reality. And Vincent, you did a beautiful job of giving examples of
Yeah.
where you can't get the sample size. So there's an infinite number of variables almost.
Overall,
So, yeah.
Santino, if you do a research about a career like Gauquelin, it's natal chart, so you won't check out the transits. If you do an event-oriented research like what I'm going to present tonight, you need either transits or secondary progression or whatever.
Right.
So it depends of what you want to prove.
Yeah.
Or what you want to search. I think we should go now and keep the other question for the second part.
Thank you.
So I would go. Do you see my part two, my screen? Angela, I don't hear you.
Yeah, we see it, Vincent.
I think
looks good.
It's ready. You see it? It's still there. Okay. Part two. Using the amount of that using secondary progressions. Oh, by the way, I do astrology since more than 40 years. I was not really attracted by using other technique than natural technique like transit. And so secondary progression is a symbolic part. It's one day for a year. So, but a few experience gave me the idea to check it because, anecdotal evidence made me go into that research, and I was very, very surprised of the results. I choose time of death for the study because it's easy to document and well-defined, thus falsifiable. The aim was to test whether secondary progression could predict much of death. Note, we assign probabilities of death to certain dates without predicting individual deaths. The statistical model of secondary progression doesn't provide individual verdicts, and results based on samples may not apply to individuals. These limitations should be taken into account. It's kind of a disclaimer. I studied the link between secondary progressions and time of death to identify a combination of weighted astrological factors that could predict a combination of weighted astrological factor. It's a signature for us astrologers that could predict the amount of death. And weighted means that some player in the signature are more important than others, and you put bigger weight those. We'll explain that. For each disease subject, I calculated their secondary progression on the day of death, as well as 500 secondary progression before that, going back 500 times 1 month at a time from the month of death. covering approximately 42 years. Example here, you have Claudio Abbado, shot, and this is the feature that permit to calculate those progression. You got the unit is 1 month, the direction is backward, and etc. We'll see it more in detail later. With a feature called animation, what you see here, Astro software allows to do this automatically and save all these results in a CSV file. We'll see it later. This is the feature. So your unit is the month, 1 month. The direction is backwards. The number is 501, 500 before that, and the 1 is the month of that, and the button to start. For each subject, these 500 secondary progression serve as the control group. So you got one progression on the day of the death, but the other progression going backwards 1 month at a time is my control group, representing months when the subject did not die. I could have used the shuffling method for generating the control group, but for an event like that, using real non-death months for each subject is more relevant than creating virtual charts. From the computer results, I recorded all secondary progression as transits, 1 day for a year, in an Excel file, noting aspects over there, and midpoint, different orb, both direct and converse. Here are the conventions used to represent aspects: C conjunction, H harmonic, D dissonant, multiple of 45. Then you take your CSV file, and I just transfer the CSV file in this type of Excel sheet. We'll see it more in detail later. All results for one subject. It's much. Why? Because 501 dates for progression, and vertically you got all the factors. I mean astrological factors. There are 232 aspects and 858 midpoints. Total 1,090 factors corresponding to 100 to 1,090 columns in this table. In fact, each of these factors is double because it's associated with its converse. For example, moon, if I say moon conjunct Mercury conjunct Venus, you got Venus conjunct Mercury, because you know what I mean. It's kind of transit. There are 501 rows in the table for one subject, corresponding to the 501 months that were analyzed. So this big table is for one subject. These 501 rows are in descending chronological order, starting from the month of death. Therefore, the first row in red corresponds to the month of death. This table shows the result for one subject. This is what we call incidence table. It means a table made up entirely of 1 and 0. 1 means that the factor at the top is present at the top of the column, and 0 means that it is absent. There's a lot more 0 than 1, obviously. This table contains 546,090 cells. To carry out this research, including the validation data, the total sample, I needed to create 853 table because I had 853 subject like this one. In total, this represents almost 500 million cells, 01 cells. Then for all the subjects grouped together, I separated this table into two sheets created with the following rows. The first sheet is the sample group, the month of death. It consists of all the first row of all the subjects. I take the first row of every subject and I made a sheet. This, month of death. Oh, excuse me. Then you've got an example here. So each row corresponds to a name. So this is the month of death of Amado. This is the month of death of Abbé Pierre. This is the month of death Edward Abbey, Carl Abraham, etc. Up to letter Y, the last one, Jean-Yann, Frank Lloyd Wright, etc. Obviously, they're not all there. I just cut in the middle. From letter A, I came to V. So in the sheet for a total sample of 853 subjects, including the validation sample, we have 853 rows corresponding to months of death for each subject, with the date of death on the right. The second sheet, it's the control group sheet, consists of all the following 500 rows of all the subjects corresponding to all the months of non-death. It's a lot bigger. It's 500 times bigger. I got my first name here, my last name here, but for Claudio Abado, you got 500 lines corresponding of his months of non-death before he dies. A control group for him. Each subject has got a control group of non-dying month. In the total sheet for the control group, we have 853 subject time 500 months, a big amount of rows, 426,500 rows, months of non-death, all subjects combined. To analyze these data, first we identify factors, astrological transit, aspect or midpoint, indicating that. For each factor, we calculate the mean for the sample and the mean for the control group to find those whose mean is significantly higher in the sample group. This is my sample with the names, and below you have the means here. And you do the same with the control group, and below you have means, and you compare. We want to determine which factor have significantly higher means in the sample group than in the control group. To do this, we perform a statistical mean test for each factor. For each column, you do a statistical test to compare the means. And you check the p-values. A low p-value indicates a factor with a significantly higher mean for the 450 months of death than for the 400. Why 400? I had 800 because I work now only with my sample. Of my first sample is 450 subject, and the control is 400 times 500. So this check is done with the sample data, not with the every data. You remember that validation is put aside, so I don't analyze those data. I've got it, I put it aside. The value you have there are the result, the p-value for each factor. when you compare the two means. Sample mean against the control mean. Pink means it's the lower one. It means that the value is below 1% here. Yellow below 5%. And green below 10%. These are the best one among all the columns. Stability criterion. I don't see that often in literature. Maybe it exists. Maybe can tell me afterward. I just created that, but maybe I suppose it exists. You tell me. Even as an astrological factor has a very low p-value, it must also be stable to be retained in our model. What do I mean by stable? This is my 400 here, up, and I divided in 3 slices of 150 each. So these 3 lines, or I mean these 3 sector are part of the 450 subset. I divided the 450 initial subject into 3 groups of 150. A factor must show consistent results across all 3 groups with a positive Z sign in each. So I just put arrows in the good one. You see here, it's positive, positive, Z positive, Z positive. It means that it's consistent. It means that moon dissonant Mercury is always significant as a that factor. Moon dissonant Venus also, and moon dissonant MC. But if you look at the others, for instance, this one, it looked nice. You know, moon dissonant Pluto could be significant. Yes, positive, positive, positive. No, negative, negative. So it's not stable. I even did an additional check of stability by adding 200 new subjects to my initial sample, which now increased to 650 subjects. And I ask that everything is stable, I mean consistent. And the only one in the list is moon dissonant MC. Positive, 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 positive. But the p-value is not so good. So to be acceptable, you need a good p-value, like this one, for instance, Mercury dissonant Venus, and also stability, which you don't have here. Why? Because it's minus, plus, minus, plus. So it's not stable. It's not, you cannot trust that, according to me. With these 200 new subjects from this stage of my research, my sample size has increased from 450 to 650 subjects. Analysis of the astrofactors. To select factors for the model, I classified them vertically based on 2 criteria. Those with good p-value under 10% and perfect stability across the 4 slices. I only retained factors for which the sample mean was greater than the control mean, meaning a plus Z, which is reflected by all positive value in the Z column, positive, 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 positive. These are the 31 astrofactors used to build the model. Note that Excel does not allow more than 200 factors. With 31, I'm okay. Assigning weights to factors with Excel Solver. Solver is a feature of Excel. Valid numerical weights, call it coefficient if you want, can be assigned to astrofactor, but they must not be assigned arbitrarily. The numerical coefficient are assigned through probabilistic optimization to find the best weighted combination for predicting the amount of debt. So for the moment, it's question mark, but you want to assign weights to all the factors you retain here. Looking for the best combination of weights for predicting the amount of debt. Here. This is my sheet for the amounts of debt. When solver assign weights to factors, these coefficients are multiplied by the value 0, 1, and then added together using the function sum product. I will explain it, giving a total scores like those shown in red for each month. So this is the total score for Abado, Abbé Pierre, 52. So you want this to be big. For instance, Robert Altman, Wemaker, 118. That's good. And here is my control group of non-debt. Same thing, solver assign weights to factors. Same method with sum product, giving different total scores here, shown in red. You want this lower when you make your research with the solver function. Here's what sum product does. Sum product is a function of Excel when used between two rows. Each element in the first row is multiplied by the corresponding element in the second row. All the products obtained are then added together to give a single result. So for a mathematician, you call that the scalar product. Here is a basic example. If my first row is 2, 3, 4, actually my row is a lot bigger, it's 1090 columns, so my row is very big. But let's say it's 2, 3, 4. Second row, 5, 6, 7. Using sum product, you got 2 times 5 plus 3 times 6 plus 4 times 7 equal 56. This function is useful for performing weighted product calculation for analysis when you need to calculate scores taking into account several factors. Solver aims to find a weight combination that maximizes the average score of the 650 debt months compared to the 35,000 non-debt months in the control group. This goal is to maximize the difference between sample and control means, minimizing the p-value. The more the difference is big here, the more the p-value will be low, thus significant. Here are the model results. Here are the weights retained for the the weights calculated for the 31 retained astral factors. You got the model here. We don't have time to analyze it, but some variables are good. Some are strange, astonishing, like moon, sun, harmonic Venus. It's strange. P-values. In sample is 51 and the mean control is 33. So it's very, very significant. Minus 33. So minus 33 is more than stars in the universe. But it's not so impressive. I'll explain why. The p-value of the astral factor model is extremely low, but it's been designed for that. I mean, how do you say that, Santino? The word you told me, I love it. You said you adjust. There's another way
It's
to
just,
say it.
yeah, you're just fitting it to training data.
Yeah, I fitting to training data. You got it. That's a good way to say it. So it's not quite impressive, but this means nothing without validation. And the validation 38 and here 33. Okay, you're bigger, but not so much. It's very close to 5%. That's validation with 200 The data shows that our model is moderately significant. It's very close to 5%. It's publishable, but a bit disappointing. I wouldn't publish that. Fortunately, there is another approach that might be more productive. Let's see results we get from this other approach. Astrolinguistics, a mathematical word approach to astrology. In 2010, I developed an astrological expert system that was integrated into Mastro software 5 years later. This expert system helps interpret charts by treating astrological information in a new way. Astro Expert System features a corpus of thousands of keywords leading to a mathematical word approach to astrology that I call astrolinguistics. Modern linguistics with probability. By compiling interpretation from 25 prominent astrological authors, American, French, British, German, Canadian, I created a corpus of astrological keywords. The system used the keyword as a building blocks of its synthesis algorithm, scoring them based on their frequency. The more a word is repeated in a chart, the higher its score. The scores are obtained by a probabilistic calculation based on binomial in chi-square distribution. The probabilistic rarity of a repeated message measures its significance. I first published this concept in consideration in 1988 to quantify significance with probabilities. A keyword gets a high score if it's frequently repeated in the chart. In summary, the higher the score of a keyword, the more its repeated presence in a chart is unlikely and therefore significant. To generate a chart synthesis as an ordered list of keywords, the expert system sorts and classifies hundreds of words by their scores. In 2016, I saw the keyword expert system potential for fundamental research. Second order modeling. Astrolinguistics offer a new research approach with a kind of second order modeling based on keywords, reflecting human thinking more accurately than linear modeling of astrological factor, as we've seen before. By using combinations of keywords linked to a set of astrological factors, this approach mirrors human cognitive processes and aligns with astrological validity, introducing a new research and interpretation paradigm. Keywords implicitly use underlying astrological factors, allowing subtle combination and enhancing intuitive analysis. The computer handles complex astrolinguistics calculation, freeing astrology to focus on a higher level thinking. For example, analyzing the keyword suffering requires identifying its full astrological signature and understanding all 135 potential factors associated with suffering. Here are the 135 factors for suffering according to the 30 books I skimmed. You see there's a lot of midpoints. They are extracted mainly from everything, also from other, like Casey and the Carters are very good too at points. And here aspects. This is an event word, both sides. Instead of directly using astrological factor, this method relies on keywords derived from them. Speaking of suffering, let's see now how I use multivariate keyword modeling to study the link between secondary progression and the month of death. Applying the same method as above to the 72 most important event keywords rather than astrological factors, I carried out a search similar to the one presented above. So in Mastro, those 72 words are similar to Santino program. I think you have 12 categories. or 10, I don't remember. It's the same, exactly the same idea. I use the same sample of 650 subjects, the same control group, and the same validation group of 203 subjects. Instead of 1090 astrological factor like before, I had only 72 event keywords. Since Excel Solver supports up to 200 factors, I use all of the 72 keywords for the model, so it's simpler. While similar to my work with AstroFactor, the word model differs mainly because it's not linear. Words are combined linearly, but their scores based on binomial and chi-square distribution are not calculated linearly. Since I use all 72 keywords factor, I was able to skip the preliminary analysis of individual p-values for each factor. I take everything. Nor did I have to meet the stability criterion in all subjects. I think I just kept all the words without skimming. For words, I use Mastro scores for each secondary progression instead of the 0-1 scores used previously. 0-1 means the aspect is there or it's not there. Now it's different. Remember that these Mastro scores reflect the size of the signature. The bigger the size, the bigger the score. As an example of secondary progression on the day of Claudio Abbado's death, here is the weighted list of words generated by Mastro expert system ranked by scores in descending order. You see the words? This is the progression on the day of Abbado's death. Stubbornness, difficulty, sensibility, irritability, inhibition, realization, determination, etc. Even love at first sight, but very, very zero, very close to zero. There's one word in the list to the left that will be extremely significant in the final death prediction model. Can you guess what word it is? Look at them. Take a chance. Tell me what you think. You can write it, or maybe you can write it in the chat. And Angela can tell us which word will be chosen.
We have someone said stubbornness, change. I say change. I think change is a good one. Nervousness.
Change actually is very low because it's
weakness.
You don't have any opportunity to. Yeah, dying is a big change, but there's no perspective of change, so it's very
difficulty.
Low. Difficulty is good, but there's one bigger. Nobody named it. No.
Stubbornness is on there.
Inhibition, which is very Saturnian.
Interesting.
Is the strongest word. To build a model, I use the same protocol for the words as for the astrological factor, with one key difference. I had to standardize the keyword scores for each subject because the words, like astrological factors, depend heavily on the natal chart. Secondary progression change slowly, so certain words of the natal chart may appear for a long time, varying greatly between subjects. You can carry all your life inhibition with different scores. So it's very important to standardize if you want to compare the subject between, as a group, all the subject. Standardizing for each subject is crucial to be able to combine all subjects in the study. Standardizing, for those who don't know what it means, you transform the scores into z-scores. A z-score is a statistical measure that expresses how many standard deviations the data item is from the mean. It is used to standardize value for comparison across different distributions or data set. The formula for calculating a z-score is the score minus the mean divided by the standard deviation. Okay. Data formatting. Here's the 5-step procedure. We're close to the end. Don't be discouraged. Here's the 5-step procedure for all the subject. 1, the Mastro creates CSV tree for the model value and subject and the validation, everything. 2, I convert in Excel. 3, table words versus dates with the Mastro scores, then the standardization, the Z-score, and finally distribution in the sample and control. So you start with Mastro with this, you remember, to calculate and the output is like this. This is the CSV file you get from Mastro for all. You got here Claudio Abado. This is for the month of death. This is for the month just preceding death. And you got a very, very big sheet just for Abado. And it's always like that for every subject. The Excel conversion will clean the table, so the date of that, the word, and the score. And you put it in a table, word versus dates in Mastro score. Then I'm going to convert those values in Z-score. Now you're ready to do the analysis. This is the distribution of sample. You remember the name are there. So each line is corresponding to the month of death with the Z-score of the words. And this is the data in control. All those lines are non-death months values for the words. The model. Here's the 2-step procedure to generate the model and results using Solver. Weighting of the 72 word by optimization with Solver. By the way, it's automated. I don't have to, I let it work. Solver will examine thousands and thousands of possibility of different combinations of weights to give you the best combination for what you want. 2, model. 3, results for model and validation. We're close to the end. Solver searches and find the combination of weights that will make the, here, we got an example of weights. A positive weight means that the word is connected to death. A negative, it's mean it's significantly absent at the time of death. So we find a combination of weight that will make the mean of the sample here, all those means obtained by, you remember, some product. So these are the means for the different subject. We want Solver searches and find a combination of weights that will make those means for months of death significantly higher than the means of these scores of non-death. So the way to check if it's higher, you take the mean for the 2 groups. I mean, you take the mean of all those values against the mean of this. Want the mean of the sample to be much higher. Here is the model. Words with their values. For instance, you see depression is 21 weight. It's high. You notice that some words have very low negative weight. These words are significantly absent at the time of death. Here are big, very big negative value. Creativity. Green color means it's mostly positive in life. -24. You're not creative at the time of death. Purpose. No purpose. Success, no success, no encounter, -47. This was automated. I didn't control anything in that. Other words have very high positive weight. Other words have like these words are significantly present at the time of death. We saw inhibition, I told you, 48, confusion, 43, suffering, 37. With large weights, 43, 48, 37, there are, oh, by the way, my values were, I forgot to tell you that it was when I programmed Solver, the value was taken from -100 to, the bounds were -100 to +100. So suffering 37, they are key players in the model. Through a purely mathematical and objective statistical process, we arrive at maximal positive weights for inhibition, confusion, and suffering, with a lot of astrofactors below that we don't see now, but we can refer to them, which, while not explicitly mentioned in depth, evokes its context in a plausible way. I didn't make it up. It came automatically. One may wonder why that itself is not among the key players. This word is simply too rare in astrological corpus and in astrology in general to gain a statistical existence. Results. We're nearly finished. 1 minute for model and validation. The model result, the training data are extremely -52. The mean sample, it's been designed to be as far as possible one from the other. I mean, mean sample is very big, 151 against 0. So it's very, very significant. The p-value of the astrofactor model based on 650 subject sample is extremely low, -52, which you understand now what it means. It means that it's at the denominator, it's like 2 divided by 1 with 52 zeros. It's like 0. It means that it look impressive, but it's not impressive without validation. Now look at the validation that's coming. This is the big surprise. This is when I open the champagne bottle. Look at that. 76 against 0. P-value 4 minus 9. So 4 divided by 1 billion. I never seen that. Validation 233 independent data show that the word model is extremely significant. Thank you for your interest.
Wow.
It's the end. Thank you.
Yeah, Vincent and I talked before his presentation about me making a little statement when he was done to make sure you're getting this. Wow. I think what we're looking at here is the revolution is happening. This, incredible journey that Vincent went on, persisting and persisting and persisting. And to get a p-value like that, it's unheard of. In fact, Vincent, you were saying, like, we need other researchers to go through your data again. It's so phenomenal.
I'm suspicious. It's too good to be true.
It's too good. We look at it and we go, this is too good to be true. But it appears that he's done everything perfectly. And this is the thing about research. There's no guarantee. You need other people to come in, repeat the study, do it in different software, analyze it, discuss it. It requires a team. What Vincent has done is simply an extraordinary
I would
breakthrough.
need good mathematician better than me to check everything. There are no conceptual mistake.
Yeah, it requires.
It's not good to be alone. It's not good to be alone.
You can't be alone, and so
no.
Everybody has a different talent, a different way, and this is the beginning of the revolution that we have data at a level.
Let me add a little more here.
Yeah.
Number one, This is phenomenal stuff. Number two, the fad or the fury or the whatever it is, the frenzy over artificial intelligence has one fundamental problem. There is absolutely no assurance. There's no evidence-based research. There is no evidence-based anything in the commercial artificial intelligence. Fortunately, the research community has been listening to some of us, and I've got an article in the November issue of the Communications of the Association for Computing Machinery on the importance of basically evidence-based research in AI. And I caution all of you who think that AI might be the answer to your problems here. That would be the biggest disaster in history in terms of what was trying to be pulled over your eyeballs.
I'm not sure I understand. Peter, do you consider my work as an artificial expert system is not intelligent?
No, an expert. Look, I am the article that I published is on the limitations of expert systems that have no assurance, where the rule-based effort is creating massive false positives and false negatives. And we built back in the 80s, we built expert systems and statistical-based systems that looked for insider misuse in computers and malware and all sorts of things. And at that point, there was no evidence-based research, and the number of false positives and false negatives was horrendous. When you're
do you
dealing
include
with,
my work in that, or you say it's different?
No. Your work is different.
Oh, thank you.
Your work is fine. I'm just pointing out that the traditional non-research AI stuff is garbage. And most people don't realize that. So I just thought I'd throw that in here. That there are other examples that I could come up with where we have failed.
I'd like to read your article on that.
I will send you a copy.
Yeah, thank you.
Yeah,
It'll
be published in November. It's on my website, actually.
Yeah, but send it to me. I'd like to read it.
I will do that.
Angela, you were talking.
Yeah, quick question. Where is your astrolinguistics published? I believe you said it in your presentation. Do you have that published somewhere?
Actually, it's kind of a reflection on. I published 7 articles, 2 in collaboration with Quantitative, and that's not in my field. But let's say 3 articles are really on those lines, and this one is coming too. So it's like by a reflection on what I've done that I just took. How can I say that? That I realized that I was doing kind of astrolinguistic or mathematical word astrology.
Right.
So it's a reflection I made recently because of you.
You're associating words
but I
with
don't,
astrological. Yeah.
So my only publication about describing this was my former lecture, and the one I will present in London, January, in London, coming London with the correlation room. I was invited there, so I present.
Thank you.
But if I publish this, I will just publish the research for secondary in depth. If it's publishable, but I just want to be sure there's no error.
So I think Christopher Benton, did you have a question? I saw that you raised your hand.
It just got answered. wanted to ask if Vincent, if his research had been published yet. I don't see it yet at published in correlation. So yeah, I was just wondering if it had been published anywhere. And if I
Next correlation article will be that one, if it's publishable, and I'd be very happy if you were one of the reviewer.
yeah, I'd really love to read it. As well as Peter's article, which is on your website, so maybe I can find it there.
Okay, we have-
Santino, did you want to
yeah.
clarify a couple of things? Yeah.
Yeah, we have some questions in the chat. I want to mention two things. One is what Vincent did is he looked at secondary progressions at the time of death to see what was happening. And to determine that, he looked at what the secondary progressions were for about 42 years prior to the death. So for the preceding 42 years, he looked every month what progressed to natal aspects are happening. And so the point is the person's 12 years old, they didn't die. 12 years and 1 month, they didn't die. 12
Yeah.
years and 2 months, they didn't die. So we're looking at every month, or he's looking at every month and seeing what was going on in the progress chart, and they did not die. And so he's comparing the previous 42 years, even if the person didn't live to be 42 years
Yeah,
old.
you're right. Even
but-
for Mozart, who died at 36, or Schubert 32, I kept 42 years. You're
Just
right.
to keep it consistent and
yes, it's a control group, so
it's a control group, so
Yeah.
it's valid. So the idea
Yeah.
is they didn't die this month, they didn't die this month, they didn't die this month. Comparing each of those previous
Yes.
months to the month of death,
exactly.
and by doing that, seeing what was happening when they died. And first he did it the typical way we do research, looking at specific astrological factors. Then by using the words, you can correct me if I'm wrong, Vincent, but I'm thinking of the words as a large collection of variables. So what you're
Exactly. Yes.
doing, what he's doing is he's using an enormous number of variables, all weighted and organized in a sophisticated way. This is extremely similar to what's going on in genetics research. And so I hope that clarifies. He's looking at progressed to natal aspects at death, comparing it to all these months when they did not die, and then using a sophisticated combination of variables that are organized under different words, and voila, finally, after all this massive work, getting
Yes,
extraordinarily
you're right.
good
And
results.
that collection of variables are semantically connected by all expressing suffering or inhibition, or so they are semantically connected.
Yeah,
And you
it's-
did that in a sense to simplify the data by putting a word associated to certain astrological factors, whether it's midpoints or transits, etc.
Yes, it's simplifying, but you take into account very big amount behind in the basement.
Yeah, it's similar to compound variables in a factor
Yes,
analysis.
exactly. Yes.
Because you have a factor like, what was one of those big ones? The top three, I forget what the words were now. Vincent,
Maybe
you
you're
had-
thinking of Henning potentials.
Yeah, so you have these big words that show up. Those words are a collection of dozens of astrological variables.
Yeah.
And so basically what we're finding out is you have to,
You're right. When you say you're a fire person, this is what you do. Exactly.
yeah. So you're basically what he's ending up with is something very similar to genetics, where if you look at one gene for eye color, there isn't one, there's hundreds. If you look at something like proneness to illness, there's thousands and thousands. So by taking all these thousands of variables, organizing them properly, it appears that we found, he found it. He found the key to these measurable results. Does that sound right, Vincent? Do you want to?
Yes, I agree. It's a good
Okay.
description.
I
Yes.
think as something also that I found interesting is that you chose a research project that was doable, where you had a large number and large group
Exactly.
of people. Because for so often we want to get in the like minute details of everything, and we just don't have them.
Yeah,
But
you're right.
this seemed like you had, over 500 people or 650.
But you know that is a taboo in astrology. I've been challenged on
Right.
that on groups.
Yeah.
That it was toxic, and there's a kind of a morbidity of working on that, but I don't see it that way at all. You describe exactly what you said is what I wanted to do exactly, and I gave example of research subject that were problematic because you don't have enough data.
And I think that's a lot of times what fascinates us, but there is a lot that is fascinating out there that you do have the data for.
And it's very easy to find date of death.
Right.
So that part, collecting the data is the hardest, longest, the more tedious part of the research.
And secondary progression is not totally reliant on the time of birth either, right? So that helps.
What do you mean?
A person's secondary progression, like the exact time of birth. So if you knew, they were born at noon.
I didn't work with angles, so I kept the moon, but so I just made,
right.
I was cautious about that. Yeah.
Yeah. Okay. Are there any other questions? You can raise your hand and we'll unmute you here.
No, excuse me. I use angle in the natal, not moving angles.
Okay.
But the angle in the natal, I kept them obviously. So I needed quality data, A and B, not less, rather than A or B. Excuse me.
Yeah, thank you.
Yeah, okay.
Vincent, that was amazing research. Thank you so much for sharing with us. And this is, the kind of thing that is important. We do have one more question. Did you consider using the actual birth data or just the date and time of birth?
No, I already answered to that. I worked with quality data. Is the question, did I consider working with date of birth without the time and without the angles?
Well, the answer is you used the birth data, date, time, and place of birth.
You can do good research without birth hour, but it's going to be harder to get results. I already done it. Anyway, I never had significant result enough to be published.
I want to just add one final comment. This massive amount of research you've summarized, it's been an hour and a half since you started. This is phenomenal that we could absorb like if some of you are saying, well, I didn't follow all that. Well, in an hour and a half, summarizing, condensing all this down, it's phenomenal that Vincent, that you've conveyed it all what you've done, and you've gone into deep. This is just a marvelous presentation.
It was as difficult as the research itself. It took weeks and weeks to write, especially English is not my language.
You did a fantastic job.
And I discouraged a few people. I mean, at least 10% left. But I made it as simple as possible. But it's like kind of nearly not 1 month work, but 1 year work, but it's maybe 7 or 8 months of full-time work.
That's a good point too, is getting this evidence-based research takes time and patience and a lot of going back and forth. So lots of comments about thank you so much. Everything was amazing. So I want to announce that beginning on October 22nd, we are going to start having a research project meeting at the 4th Tuesday of every month. And the hope is discovery through collaboration. We are going to be discussing the first meeting, probably will be mostly like basic research methods and best practices. No matter what your comfort level, we encourage you to join, even as an observer. Eventually, we will set up more groups and more convenient to people in different time zones to research different topics, have more educational opportunities, and hopefully obtain well-researched discoveries. So we thank you so much for being here. When you leave the meeting, you're going to be taken to a quick 5-question survey just to ask a couple questions. We are a nonprofit 501c3 organization. So if you would like to donate even $5 or $10 to help with operational costs, we greatly appreciate that. Please email us your questions at info@cosmobiologyinstitute.org. And you're all invited back in early December for our next guest presentation. We will send you more information on that to come. So thank you all. And thank you so much, Vincent, for all of your work and your presentation to us. It was incredible. Thank you, everyone.
Thank you.